Hi viewers, we will continue from question number 7 onwards. So here we have P, Q, R and S are points on a circumference of the circle. So as you can see that P, Q, R, S, there are 4 points which touch the circle. So whenever you have a quadrilateral inside the circle and that all corner points touch the circle, that is called cyclic quadrilateral. We call cyclic. Okay, cyclic quadrilateral. Quadrilateral. In cyclic quadrilateral, we have sum of opposite angles always equal supplementary or 180. Means here opposite angles are X, are Q and S, P and R. Over point is to find out X is what. Okay, so we can say that X plus 124 is equal to 180. This is the cyclic quadrilateral theorem. Okay, this property help us. Now we can take 124 other side, so it is 180 minus 124. That gives us, if we subtract 124 from 180, it gives me 56. So that is our answer. The reason is we find out the X, and the reason is we apply cyclic quadrilateral theorem. Okay, I hope so it is clear. Now we move on next part of this question, which is the diagram show the circle and a tangent at T. So we can see that a tangent line. This is basically a tangent line. This line which pass through T and touch the one point of a circle. So this line is called tangent line, and this is the chord. This line is called chord. So we know the one rule of circle theorem, which is called alternate segment theorem. Alternate segment theorem, and that theorem says the angle between tangent line and the chord, which is W, is always equal to the opposite to this chord. So opposite to this chord angle is 70, this one. So we can straight away say that W equal 70 degree, and the reason you can write alternate segment theorem. That is the reason. I hope so it is clear. We move on next. It's very straight question. So next part of this is little bit tricky, but we will try. They want us angle Y, and if I check A, B, and C are points on the circle, as you can see that A, B, B is not A, C, and D. Yes, A, C, and D. These 3 points on the circle and center O. This is exactly center. It means O to C and O to A are radius equal in length, and BA and BC are tangents. BA and BC. So tangent lengths are always equal. So BA and BC. And remember that whenever we have tangent lengths, so that this BO is basically angle bisector. So Y is the half of this all. If you know all this, so Y is the half of this. That we will see at the end. So first thing we can say that this angle, which is you can see that at point D is angle subtended on the circumference, is always the half the angle subtended in the center. This is center. Or in other words, one theorem, same theorem you can say that angle in the center is always twice the angle subtended on the circumference. Means this angle which I marked is always double of 47. So if we check angle AOC is equal to 2 multiplied by 47, which is equal 47 multiplied by 2, 94. So we can say that it's 94. Remember one thing, as I said, O to C is radius, okay, because O is the center. So this is radius. This is O to A is also radius. So angle between the radius and the tangent line is always 90. This is again one theorem we already learned in the previous lectures of circle theorems. So that theorem was, if you have a circle and we have the lines, let's suppose this is center to end radius, okay? And a line pass through by touching this. So we always say that angle between the radius, this is radius, and this one is tangent line, okay? Tangent line. Angle between radius and tangent is always 90 degree. So same concept, this BA is tangent line, O to A is radius. So angle between these is 90 degree. Same as here at C, angle is 90. So remember that A, O, C, B represent four corner points. So means quadrilateral. So sum of angles of a quadrilateral, which is kind of kite, so is equal to 360. Means we can say that 90 plus 94 plus 90 plus, I'm considering full this. Let's suppose we can choose any other point. There is no x here, so I'm considering x full. So x is equal to 360. So we will add all these 90 plus 90, 180. So 180 plus 94, that gives me 274. 274 plus x is equal to 360. So we are looking x. So 360 minus 274, which is equal 86. And y is the half of this x because they divide as like angle bisector. Okay, BO is the angle bisector which divides this full angle x exactly two parts. So y is the half of x, means y is equal to 86 divided by 2, which is equal 43. So we found the angle y, which is 43. I hope so it is clear. So which rules I apply, that you can give as reasons. One reason you can give this one, angle between tangent line and radius is always 90. And the last I write sum of all the angles of quadrilateral is add up to 360. This is another reason. And the first I use a reason, angle in the center is always twice the angle subtended on the circumference of circle. I hope so it is clear. If you have any question. Fine. Now we will move on another question, which is A, B, C, D are points on a circle center O. And remember that it means if this is the center, so center O to D is radius, O to B is also radius. And angle at X, we don't know. We don't know Y, we don't know Z. Only the thing which we know in this question, it is X plus Y plus z equal 290. And remember one more thing, we can apply the theorems also. As we know that angle in the center is always twice the angle subtended on the circumference, means y is equal to 2x, double of xy. Okay, this is the rule, theorem. And one more thing, we can say that this angle, which you can see that z is basically half of this. Now, half of how to find this angle? If we consider this one as 2x, which is y is equal to 2x, okay? So total are 360. If I try to make the concept, means here you can say that z is equal to half of this angle. So the total is 360, means 360 minus 2x, that gives us this angle. Yes, 360 minus 2x, that gives us this angle. So which is 360 minus 2x, and z is the half of that angle. Okay, means divide by 2. So again applying the theorem. So if I try to simplify, this could be 2z is equal to 360 minus 2x. Take 2x from right to left, so it would be plus 2x plus 2z is equal to 360. I know 2 and 2 we can take common. So x plus z is equal to 360. And then x plus z is equal to 360 divided by 2, which is equal x plus z equal 180. So these two relations will help us to find out x and y. Now, Originally, which is given, it is x plus y plus z is equal to 290. This is given, okay? This relation is given. So I'm trying to make the form like x plus z. If you write or rearrange or shuffle it, plus y is equal to 290. Why I write x plus z? Because we know x plus z equal 180. So 180, and y, I said it is y is basically equal to x, double of the angle which is subtended on the circumference. 2x is equal to 290. In this way, we can find out x easily. So 2x is equal to 290 minus 180, which is equal to 90 minus 180 gives me 110. 110. So x is equal to 110 divided by 255. Divide by 2. Yes. So we find out one angle, which is x, same as we are looking y. And we already know that y equal to x. Y equal to x means double of 55. So y is equal to 110. So once you know that x and y, we can replace in the original function, which is x plus y plus z is equal to 290. So x and y we know that, which are 55 plus 110, and we are looking z. So 110 plus 55, it is equal 165 plus z 290. So z is equal to 290 minus 165, which is equal 125. So we find out all these three angles: x equal 55, y equal 110, and z equal 125. I hope so it is clear. Now we try question number 10, which is A, B, C, D, and E are points on the circle. So AC is parallel to ED. AC. As you can see that they mentioned one arrow here. So AC and ED are parallel. So this we will use the concept. Remember that when we have parallel lines, so we can bring the concept of alternate angles, corresponding angles, like alternate angles are equal. For example, if I draw one line, see, maybe you remember, this is one line, this is another line, and we have one transversal. This is called transversal. So if we have two parallel lines, we can say that this is first line, this is second two parallel lines, and this one is transversal angle, alternate angles. These are the alternate angles opposite to the transversal. Both are interior or both are exterior. Let's suppose this is A, this is B. So we can say that A equal B, and the reason is alternate angles. Okay, alternate angles are equal. Same as we have corresponding angles. Those are same side of the transversal. One interior, one exterior. For example, here we have C. So angle A and C are equal. But A and C are corresponding angles. Corresponding angles. And corresponding angles are equal. C and B are vertically opposite angle. B equals C. These are vertically opposite angles. So here I will not use all, maybe that first one alternate. But see one more, if you check carefully, they mention one line, this one chord AD, okay? So if you check chord AD, this is the same segment. If you move from A to B and B to D, and look, no, again I'm drawing one line, A to C and C to D. In these two angles, 70 and X, maybe you checked the chord is same, AD is same. So when we have same chord or same segment, so angle on the same chord or and subtended on the circumference, they are always equal. So means 70 is equal to X, or X equals 70. We can say that angle on the same chord, which is subtended on the circumference, are always equal. So x equals 70. This is your first answer. Means this one is also 70. Now, what else we are looking? We are looking y. So remember that if I remove this one, these all, because now we will try to think about parallel lines concept. For example, one line is here, this is one line, and second line here. And if you check AD, that is that you can extend this line, you can extend this line. This one is the transversal, this one. This one is the transversal. So it means if this is the transversal of the parallel line, so we can say that uh, these angles like angle 34. So this one is also 34. Alternate angles, yes. So if this one is 34 and we are looking angle Y, and remember that one more thing, this angle E and angle 70. If you check the full, like if you connect this one, this point C, point D, point E, and point A, all are on the circle. So it means they represent a cyclic coordinator as well. So angle this one, we can suppose that let's suppose Z and 70, sum of these two angles, Z plus 70 equal 180, cyclic quadrilateral concept. Okay. So 180 minus 70, that gives me 110. So if we know this angle 110, this we know already, we can find y easily by applying triangle concept. Y plus 110 plus 34, y plus 110 plus 34 is equal to 180, because angles in a triangle is add up to 180. So 110 plus 34, it gives me 144 equal 180. So y is equal to 180 minus 144, which is equal 36. So this is your answer of y. So we find out y as well as x. These are the target to find x and y. I hope so it is clear.